Hello and welcome back to this Python series. For this tutorial, we are covering try and except statements in Python. So a major reason why try and except statements are important for your program are that they allow you to handle errors a lot more efficiently. And what I mean by that is, without these statements, if an error occurs somewhere in your code, most of the time it can lead to the termination of the entire program. And if you're still in the middle of making the program, it might not be an issue, but for your finished result or your finished product, you would want the program to be able to handle errors without the entire program crashing. In most cases that is, because sometimes it depends on the program that you're trying to write, but for the majority of the cases, you would want your program to be able to handle errors without the entire thing terminating just because of one error. So try and except statements will help that happen. And I'm going to show you an example of a program that will crash, and then we're going to be building on that same example, and then we'll be using try and except statements in order to handle those certain errors. So then you'll be able to get more understanding on what I mean when I say try and except statements will allow you to handle errors a lot better. So for this example, I'm going to make a new function, and this will be one that will divide 50 by a number. So let's pass it a parameter called answer, and let's simply return 50 divided by whatever number we put in that. Now we can test that this program works first by doing divide 50 by whatever you called your function, and let's pass it the number 10. So essentially it's saying it will divide 50 by 10 because that's what we passed for answer. Now let's see if this program works. And you can see 50 divided by 10 is obviously 5. Now let's do an example of what will happen when the program crashes. So let's copy and paste. I'm going to put this 50 divided by 5, divided by 2, divided by 0, divided by 5, divided by 3. And obviously you can tell this is the line that will cause the error. And let's demonstrate now by running the program. Your program doesn't know what to do since it can't obviously divide by 0, it doesn't know what to do once it encounters this error, and therefore the program just crashes. Now it gives you this zero division error over here. So like I mentioned earlier, you'd want your program to be able to handle errors without crashing, because for this example that I just showed you, you can see that we have some more instructions to execute right underneath that line that caused the error. However, since the program now terminated due to encountering this error, it does not accomplish the subsequent lines right underneath that line that caused the error. So we're going to do an example now of how to handle this error without the program crashing, and then it will go ahead and accomplish the rest of the instructions provided. Here we'll insert our try and except statement. So in our function, let's make a new line and type in try, colon, and then this line that says return 50 divided by answer, we'll press tab so that it's a new indentation. And then the next thing we're going to do is type except zero division error, colon. And then here we'll return none. And now that should handle the error so that now the program knows what to do when it runs into a zero division error like the one over here. Instead of crashing the whole program, it will now run this block of code and then head over to the next instruction. So let's demonstrate by running this program a second time. And as you can see, it successfully executed these two lines of code that it did not execute the first time, now that we've had the try and except statements in order to handle that zero division error problem. So now you can see over here we return none when we handle the division by 0 error. And then it goes ahead and divides 50 by 5, that is simply 10, and then it divides 50 by 3, and that's a 16.6666. Like, you can round that up obviously if you want to, and that is it for this program. So you can see that unlike earlier where it crashed and it didn't execute what else was underneath that, now you can see that it goes to the rest of the program after encountering that error. So that's just one example of a simple program that can handle that kind of error a lot more gracefully so that it doesn't terminate like it did over here the first time without the try and except statement. And you can actually make this also say something else, because right now it only says return none. We can also make it say something like, you can't divide. Oh wait, let me make this double quotation mark because we have an apostrophe over here. You can't divide by 0. But that is not required, but you can also make it say that if you want. But as long as it says none, I'm honestly fine with that. So I'll just get rid of this. And let's go and do some more examples of this. Okay, so since we're done with the previous example, I've gone ahead and cleared up the interactive shell. Let's get rid of this program entirely, and we're gonna do another example of this. So let's do print, enter any number, and this program will take in any number that the user inputs. So let's do that by saving it into a variable called user input, and we'll call in the built-in function called input. And then let's do our if statement, and we're gonna convert that to an integer data type first. So int user input is greater than or equal to 10, and then it will say print you entered a number equal to or greater than 10. And then we'll do else your number is lesser than 10. So this if else statement will just basically say, if you enter in a number equal to 10 or greater, run this line of code, or else run this line of code if the number is less than 10. So let's run this program, and let's do 5, so that's obviously lesser than 10. Let's do 18 for our next answer, and then let's do 10. You can see that our program is working as intended. Now let's make this program cause an error, so let's run this program again, and see what happens when I type in 10, but we're gonna spell it out instead of typing in the number. You can see that we have an error when we do that, because right now it's checking for an integer answer, but if we type in a string, it will give us a value error. And we can handle this again with a try and except statement. So to do that, what we're gonna do is we're gonna first make sure you copy this if else statement, and then erase it, and then type in try colon, and then paste that in, and make sure that your indentations are fixed when this happens. So right now, the print line should be indented, and so should this one underneath else. And then underneath this is when we type in except, and then here we are doing a value error problem. So instead of the zero division error that we had earlier, this time it's a value error. So now it's saying, if we get this kind of error, run whatever line of code is inside this except block over here. So colon, type in print, you need to enter a number, not a string. So it's gonna search for the integer data type, not the string data type. And if you type in a string data type, that is when this error will happen and the program will crash. Well, now with this, it should instead print this line instead of crashing the entire program like it did earlier. So if we run this program again, and let's do 10, it will say you need to enter a number, not a string, because now this try and except statement will take care of that kind of error. If you run this program and type in any other number, let's do 200. It's obviously that's greater than 10. Let's do -3. Your number is lesser than 10. So that's one other example of a try and except statement, this time handling a different kind of error than the previous program. So you can see that it's a very handy way to make sure that the program doesn't end up being a disaster when it enters, or when it encounters a problem like the two that we showed earlier. And I also wanted to note down that you can actually have multiple except blocks in your code, so it doesn't only have to be one or the other. So right now we have a value error except block. Let's also add in except zero division error like the one earlier. And then we can do you can't, let me make this double quotation marks, you can't divide by 0. And yes, we're doing double quotation marks for this because we have an apostrophe over here, and we want that to be inside one string without ending the previous one. But anyway, so back to my point, you can have multiple except blocks as well, and it's actually good because let's say that you have a program that you might be able to enter one answer that causes the value error, but if you accidentally do one that causes a zero division error instead, your program will crash since it only knows how to handle the value error, but it might not know how to handle the zero division error. So it's good to actually have both of them into one program so that you're able to handle multiple types of except problems, and your program won't suddenly crash because your program will be prepared for that kind of outcome. And then here's another one I wanted to show you as well, where you can do except exception as E, and this block will handle any other except problem that is not covered in the previous blocks over here. So right now it's saying that any other exception that is not a value error or not a zero division error, this is the generic one that will run for any other kind of errors. So that's one way that you can handle that as well. You can add some more except blocks if you want to, but this over here is kind of a general thing. It will just take it will just handle it so that the program will not crash. It will handle any other sudden error that way. So I just wanted to demonstrate that you can do that as well if you want to handle multiple types of other problems, such as the problem above. Okay, so to recap, try and except statements just make your program handle any errors without the entire program terminating. The try block contains the code that might raise an exception, such as this if-else statement over here, and then the except blocks follow the try block and contain specific code to handle specific exceptions, and then the exception SE block will handle any unexpected exceptions that were not caught by the previous except blocks, like the value error or the zero division error ones. And you can have multiple except blocks to handle different types of exceptions so that your program knows how to react to each one without it needing to crash. Okay, so that's it for the try and except lesson. Thanks, and stay tuned for the next Python lesson.